All right, semester one review for the final. So let's just get into it. It's quite a bit. All right, number one. Looking at this graph, remember discrete is when there are a bunch of dots, right? It's strictly dots. That's what discrete is. So discrete is dots. Discontinuous, we're looking for gaps. And then a continuous function is just a one line, one solid line. So this picture is definitely continuous. Right, it's one solid line. It doesn't have gaps and there's not dots. All right, the domain, remember it's the x values. So we're looking at the x values. So it starts, we'll call this -2. Oh, I'm sorry, +2. And then it goes to the arrow, which is infinity basically. So this is 2 bracket because it's a closed circle towards infinity. The range, that's the y values. So we're looking at the y value. So we'll call this +3. So it's 3 bracket because it's a closed circle. And goes towards -infinity. Oh, but look, it goes down. So it always comes from -infinity. But the arrow is going down towards -infinity in terms of y. In terms of x, it's going towards +infinity, right? Because it's going to the right constantly. And then for y, it's going down constantly. So it's coming from -infinity. The big one about this, continuous. Continuous. All right, number 4. Substitution method. All right, so we're going to solve for one variable. Here it's already solved for x. So we're just going to rewrite it. I'm going to take all of this and plug it into here, right? Because we're substituting one variable into the other equation. So this is 9, and x in this case is 4 plus y minus 10y is equal to 45. And now we're just algebra 1, right? One variable. We're solving for y. So we have to distribute into the parentheses. 9 times 4 is 36. 9 times y minus 10y is equal to 45. Combining like terms. So we get 36 minus y, right? 9 minus 10 is equal to 45. And then solving for y, minus 36, minus 36. So we're going to get -y is equal to 9. 45 minus 36 is 9. But we want y by itself. So we're just going to divide by -1 or multiply by -1, however you feel. So y is equal to -9. Y is equal to -9. Okay, that's only half the answer because we want to figure out what x is. So if we plug back into the original to solve for x, we get 4 minus 9, right? 4 plus -9, the same as 4 minus 9. So 4 take away 9, x is -5. So here you have 2 answers. Right. On a multiple choice test, you can always just take the answers and plug them back into the equations and see. So that's one way to think about it. All right, 5. Okay, we're solving a linear inequality. So this is less than or equals. And we're solving for x. So I'm going to start moving the x's one way and the numbers the other way. Doesn't matter which one you move, really. I could have subtracted minus 5x, but then we would have got a negative number, right? If I would have did minus 5x to both sides, 3 minus 5 would have been -2. I try to avoid negative situations. So this is 2x minus 8 less than or equal to positive 10. You need to put the positive? No, not really. Adding 8 to both sides. So this is 2x less than or equal to 18. Solving for x. X is equal, or x is less than or equal to 9. So when you're solving for x, remember when you divide by a negative or multiply by a negative, you have to flip the sign. That's one of the reasons why I try to look ahead and I try to avoid negative situations. Because if you forget to flip the sign, that will lead to the wrong answer. So x is less than or equal to negative 9. So in terms of a number line, this is negative 9. It's a closed circle, and we want less than, so this direction. So x less than or equal to negative 9. So inequality is the one that has the number line. Okay, number 6. Is the ordered pair 4, negative 2 a solution to the inequality? Hint, plug in the values. So always look at the hints, right? If they're given, they go a long way. So this is x and this is y. So we just plug in our numbers. 3 times 4 plus 2 times negative 2. Is this greater than 12? So we have 12 on this side. 2 times negative 2 is minus 4, right? 2 times 2 is 4, negative. And is this greater than 12? So 12 take away something. 12 take away 4 is 8. Is 8 greater than 12? That's the question. It's false. So that means 4 negative 2 is not a solution. So is it a solution? No. No, it is not. Okay. Find the roots, which means the x-intercepts, then test a point on the graph. Okay. Hint, rewrite in standard form. So remember, in standard form, we have everything to one side, typically the left, and it's going to be equal to 0. So for the moment, I'm going to rewrite this as equals negative 10, right? I don't care about the greater than or equals, right? Leaving it as greater than or equal kind of leads to issues if you don't understand what's going on. So if you just rewrite it for a moment as equals and then start solving this as you would any quadratic. I'm going to add 10 to both sides. Now, a rookie mistake would be to say negative 7 plus 10. You don't do that because negative 7 has an x. 10 is just a constant. So what this means is x squared minus 7x plus 10 is equal to 0. So we want to see where is this true, right? We're going to get two answers. Typically, you can do the quadratic formula. I like this little x method. Typically, when x squared is 1, right? The little x method works out very nicely most of the times. So I want to figure out what numbers multiply to make 10 that add up to negative 7. So we just start running through all the multiples of 10, right? 1 and 10, 2 and 5, and that's pretty much it. Okay, so 1 times 10 is definitely positive 10. But when you add them together, we get 11. We want to make a negative when we add them up. So that means the big number must be negative in both cases. Okay. However, when we make one negative, now when we multiply, that doesn't make positive 10. So it needs to be both multiples need to be negative. You just have to do quite a bit of these, practice with them to understand the logic behind it. When you're multiplying two numbers to add up to a negative, right? So the point is both need to be negative, right? Because negative 1 times negative 10 is positive because the negative times the negative is a positive. -2 times -5 is also positive 10. But there's only one that makes -7, and that's -2 and -5. So what that means is these numbers drop right into the factors. X minus 2, X minus 5. Right, those are the factors. And we want the roots. So inside lies when it comes to roots. So the roots are going to be X equals positive 2, X equals positive 5. So those are our roots, 2 and 5. So if we go to the number line, 2, 5, we know that it gets the closed circle because it's or equals. And then we have to test a number. So it's best to test 0 when possible. Here it's very possible, right? 0 is going to be somewhere over here. So if I'm going to plug in 0, and if it's true, we're going to shade on this side that contains 0, and then this side, right? If 0 is true. If 0 is false, then we shade inside. If it's false. All right. So let's test it. And where I mean test it, you test it back in the original problem, the original inequality before you change the sign. So we're plugging in 0. So that's right. This is the reason why 0 is nice, because all the x's just go to 0. So 0's on the left, and we say, is 0 greater than or equal to -10? 0 is definitely greater than any negative number. So this is true, right? This is a true statement. So that means we shade on the side that contains 0. And since we're shading on that side, we shade on the other side as well. Like they come in pairs. So any number that's in the shaded area is going to make this true. If you chose, say, 3 or 4, then it would be a false statement. Anything in between 2 and 5 would be false. Okay. Number 8, find the roots. We're using whatever method we want, right? We can do slide and divide. We can do quadratic formula. Quadratic formula in this case, because the numbers are kind of large, you might run into some multiplication areas or errors. So slide and divide, I think, would be the best. Slide divide method. So when you slide the 3 over, you multiply. So that means we're gonna have to divide by 3 later on in the process. So x squared minus 14x minus 15, because 3 times 5 is equal to 0. So this type of problem can definitely be factored using the method that we used above, right? The typical x method. So looking at the x method, we say, okay, -15, numbers that multiply. And when we add those numbers together, we want to make -14. All right, so looking at numbers that multiply to make -15. We have 1 and 15, 3 and 5, and that's pretty much it. Okay, so now we do like a quick little analysis. Right, when we multiply, they have to be negative. So one of them has to be negative. Well, which one? Is it the small one or the big one? Well, you look up here. Because this is negative when I add them together, that means the big one needs to be negative. So 1 plus -15 is definitely -14. So that's the one we want, right? 3 plus -5 is -2. So not that one. All right. Now that we found the numbers that we want, we put them in factors. X plus 1, X minus 15. And here comes the most, right? Typically we would say, okay, inside lies, and then we go to the roots. But we have to remember about the divide part. Right, we have to divide each of these numbers by 3. And then reduce when possible. So 1 over 3 doesn't reduce. So right now, I could turn that into a root. Inside lies. So x is equal to -1/3. 15 over 3, that does reduce. Reduces to 5. So x minus 5. So the root right? The root would be x is equal to positive 5. So slide and divide, right? You slide that a term over, multiply it by c, and then you analyze, right, using the x method or factoring, however you want. And you got to remember to divide the number out. Because we slid the 3 over, we have to divide by 3 and then reduce when possible. If it doesn't reduce, it doesn't reduce, right? Like you're pretty much done. You just inside lies at that point. So the answer for the roots are x equals negative 1/3 and positive 5. Okay. Number 9. All right, so now they're telling us to use the quadratic formula to solve. So a quadratic formula, I'll write it down. Negative b plus or minus square root b squared minus 4ac all over 2a. Right? X is equal to this, right? X is equal to this. So we're just going to plug in a, b, and c. So a is the number in front of the x squared, b is the number in front of x, and c is the constant. So what I'm saying is a is equal to 1, b is equal to negative 2, and c is equal to 8. So we just plug these in. Now this is the most missed idea, right? Because negative b is in the formula and b is negative. So you have to account for that, right? Negative 2. Plus or minus. Here's the second most missed thing. If you're using a calculator, typically you got to put negative 2 in parentheses if it's negative, right? Otherwise, the calculator will only square the number and not the negative sign. Minus 4 times a, which is 1, c, which is 8. All over 2 times 1. So there's the setup into the formula. Now we just start simplifying. Negative, that's positive. Plus or minus. Negative 2 squared is 4. Minus 4 times 8, 32 over 2. So this is going to be, what's 4 take away 32? Negative 28 over 2. Okay, we're almost done. Negative inside the square root always comes out as I. We never leave a negative inside the square root. Furthermore, 28 can be broken down. 2 and 14, 2 and 7. And then we take out the pair. This 2 will come outside. So our answer is basically 2 plus or minus the 2 that comes out, the I that comes out. Square root is 7, right? The single's left behind. Over 2. Okay, another missed concept is when you come to reducing, right? The only way to reduce this is if all 3 terms have the same common factor. In fact, they're all 2. So the 2's here can cancel. You got to cancel all 3. You can't just cancel out 2 of the 3. So whenever you cancel something out, it leaves behind a 1. So our answer, final, 1 plus or minus I root 7. You don't really have to put the 1 in front of the I. It's implied. And you don't have to put over 1 either. Right? That's pretty much how that is. All right, 10. I know I'm going quick, but you can always pause the video and then review what I said multiple times. All right, so we're looking for the vertex. The vertex is h comma k. Inside lies. So this is positive 8. Outside tells the truth. Negative 17. All right, there's the vertex. It doesn't matter what's in front, right? What is in front is irrelevant. Inside lies, so positive 8, and the outside tells the truth. So the vertex here is 8, negative 17. Okay. Vertical dilation, right? Dilation is the A value. It's the A value. And remember that the dilation should always be positive. So we just want just the number. So here the dilation would be 4, right, because of the A value. And the y-intercept, when it's in standard form, is this number. That one's very important, right? When you have the standard form and you're asked, what is the y-intercept? Well, it's just it's the C value, right? So some notes. This is the A value. This is the C value when it's in standard form, right? When it's in standard form, that's a big one. All right. Number 12, we want to write a quadratic equation in standard form that has this shape when you know the x-intercepts, right? I know the x-intercepts. This means that x is equal to -6 and x is equal to 7, right? Because they're giving me the roots. They're saying these are the x-intercepts. This is where it crosses the x-axis at -6 and 7. All right, these are the roots. Working backwards, we need to turn them into factors. Now, typically we're used to going the other direction, right? The inside lies. The inside must lie. So this means x plus 6, x minus 7, right? Because it's the opposite. And now to get it into standard form, we just distribute. X times x, x squared. X times -7, -7x. 6 times x. And 6 times -7, -42. And then combining the like terms, we arrive at the final answer. X squared, -7 plus 6 is -x, minus 42. So when you have the roots, you can take the roots, turn them into factors, and then distribute. All right, 13. So describe the translation. So what's happening here? All right, inside's going to lie, right? Inside, this is my left or right. Right, this is left or right. And inside lies, so positive, right? X plus 4. It's going to go left. Left, how many? Left 4. And then outside, this is up and down. And this one behaves normal. It's net -6. So it's going to go down 6. So those are the answers, right? That describes the translation. It goes left 4 and down 6. Right? And it's a V shape. Do I really care about that at this point? No, I really don't. Right? But it looks like this. And it's going to go left and down. So something like that. It's not to scale, but that's what it's going to look like. Left and down. All right, 14. I-22. We all love complex numbers. So there's a very particular list. I to the first power is just I. I to the second power, -1. I to the third power, -I. And I to the fourth power is +1. So I, -1, -I, and 1. That order. And it'll start repeating, right? I to the fifth, it will just start over, back at the top. To 6, 7, 8, and then start over again. 9, 10, 11, 12, 13, 14, 15, 16. So every multiple is a 4. So 2 ways. Either you can just start at 1 and just start counting to 24. It's like a rookie way of doing it, but it can be done. Or if you take the number 4, because we know it cycles every 4, and divide it into the power. And whatever our remainder is, that's the number that we look at. So 4 goes into 25 times. 5 times 20. 5 times 4 is 20. Subtract. We get a remainder of 2. Because it's a remainder of 2, we look at the second power, right? Whatever that remainder is. Right. Okay. So this is going to be, the answer is going to be -1. Right. That means that I to the 22nd power is -1. It's equivalent. Okay. 15, simplify. So here the strategy is to use FOIL. Right. You're going to distribute everything using FOIL because it's multiplication. Right. There's a difference between that, like 15 and 16. Like 16, this isn't FOIL. It's subtraction. So it's completely different. So when it's multiplication, you do FOIL. 4 times 2, 8. 4 times 3, 12i. -3 times 2, -6i. And then -3i times 3i is going to be negative. 3 times 3 is 9. I times I is I squared. So the two things here, combine like terms and then account for I squared. All right, we just learned that I squared is -1. All that does is change the sign in front of the 9. That's all it does. So our answer, 8, 12 minus 6 is going to be +6i, and then plus 9, right? The -1 just changes the sign. And then final answer, combining like terms, 8 plus 9. 8 plus 9 is 17 plus 6i. Right, that's our final answer. So FOIL is a big one, and then understanding that I squared is -1. I times I is I squared, which is -1. Okay. 16. So here, like I said, we're subtracting. So one technique is to distribute the minus sign first and then combine. So if we distribute the negative, when you rewrite it, you get 4 minus 3i. All right, the negative distributes, making -2. Distributes again, making -3i. And now you just combine like terms. 4 minus 2 is 2. And then -3i minus 3i is -6i. I'm going to move this out the way. Oops. Can't. Okay, whatever. All right. 17. Distribute the minus sign first and then combine. It's basically what we just did, except instead of distributing negative, you're distributing -5. It's the only difference. So that's going to be 4 minus 3i minus 5 times 2, which is 10. -5 times 3 is -15i. All right, combining 4 minus 10, -6. -3i minus 15i, -18i. All right. All right, everyone's favorite, completing the square. All right, I'm going to complete the square to put it in vertex form. However, if this was a test, an actual test, multiple choice test, you can always take your answer choices and expand them out, right? Which I'll show you here in a second. Okay. So now, again, depending on who your teacher is or who taught this to you previously, there's different ways. So the way I go about it is slightly different from everyone else, but it makes sense to me. So what I'm doing is I'm saying x squared plus 10x plus 6. I'm just taking the problem and then writing it down here. I set it equal to 0, right? Because that's how I learned. I set it equal to 0 for the moment. Okay. First step I do, I move the constant to the other side. So we get x squared plus 10x plus something, right? Because that figure moved, but I'm going to replace it with something here in a minute, is equal to -6. And again, plus a blank. All right, I put these two blanks here because it's an equation. It's a balancing act. If I add something to one side, I have to add it to the other side to keep the scales equal, right? So the question is, what do I add? Well, let's think about this for just a moment. I got to take half. So the process goes, you take half of the b value. B is 10. So if I take half of 10, I get 5, right? 5 is half of 10. Okay, this 5 value is very important. I say it's important because it shows up here, right? This 5 will always show up, or when you take half of b, that figure will always show up right here. And step 2 is you have to square that number. This is the value that I add to both sides. So 5 squared is 25. So that's what I add here. And this is what I add here. All right. If you were to expand x plus 5 squared out, right? X plus 5 times x plus 5, you would get x squared plus 10x plus 25, right? It just works out that way. That's the way it works. Okay. On the right-hand side, -6 plus 25. So -6 plus 25 is 19. All right. So you're basically at the vertex form. However, the vertex form says everything needs to be on one side. So what I'm going to do is I'm going to subtract 19 from both sides. So the vertex form is x plus 5 squared minus 19 equals, now I could say 0, but really it equals y. So this would be the vertex form. And this would be one of the answers that I'm looking for in the multiple choice. Now, if you want to bypass all of this process, you just look at your answers and then you just start expanding it out, right? Like one by one. So if you were to take, say, if this was answer A. So what I would do, typically is the one with the minus sign, right? So what I would do, x plus 5 times x plus 5 minus 19. I know that when I FOIL this out, I'm going to get x squared plus 10x plus 25 minus 19. And that would be x squared plus 10x plus 6. And now look, that matches the original problem. And that's how I know that that's my answer. So if you don't want to complete the square, if you're not nice at completing the square, that's fine. There's ways around it, particularly in a multiple choice test. So you can start at the answers and work your way backwards. That's my recommendation. All right, vertex form is nice because when you ask, where's the vertex? Well, inside lies, so -5. Outside tells the truth, -19. So the vertex is -5, -19. Right, it's a point. All right, number 19. This is basically the same thing that we just did, completing the square, but this time the difference is A is different from 3. I'll be quite honest, I don't care about this problem. All right, let's go to number 20. So for number 20, we must have two answers, right? Because it's absolute value. So if you remember this, absolute value has two answers, a positive and a negative. 2g minus 9 is equal to 11. 2g minus 9 is equal to negative 11. So you just change the positive to a negative. And we just solve for g, right? It's a one problem, or it's a one variable problem, plus 9. So 2g is equal, 11 plus 9 is 20. Divide both sides by 2. G is equal to 10. So one of my answers, g equals 10. The other answer, I add 9. So 2g is equal to negative 2. Negative 11 plus 9. Divide both sides by 2. And g is equal to negative 1. Is there an answer slot? No, there isn't. All right, so these are my two answers. So again, absolute value, you're going to change the answer to a negative for one of them, right? It's drop the absolute value bars, leave it positive, and then drop the absolute value bars and change the answer to negative. And then just solve for g. You get two answers. If you want, you can plug them back in and check it. Okay, simplifying fraction with the square root. So here the deal is that we don't like square roots in the denominator, right? Square roots in the bottom of a fraction are bad. You always have to simplify it somehow. So what we're going to do is, the word is called conjugate, right? The conjugate pair. So this is 2 minus root 5. So I'm going to say 2 plus root 5, right? This would be the conjugate pair. You do the opposite symbol, right? It's not always plus. If plus was already in the denominator, then I would use minus, right? It's always the opposite. Not only that, but it's top and bottom, right? It's got to be the same thing, top and bottom. So when you start multiplying, you're going to distribute the 6, top times top. So 6 times 2 is 12. All right, 6 times root 5, not 30, right? 6 is outside of a square root number, and root 5 is inside the square root number, so to speak. So you can't mix and match, right? There's no way to ever multiply 6 times root 5. So what happens is we just put them together. 6 root 5. Now, if root 6 was on top, that'd be a different thing, right? Like when you're multiplying square roots, inside times inside. But if one's a square root and one's not, there's no way to ever multiply these numbers together. You just put them together. Okay. For the bottom, so in this case, when you're doing a conjugate pair like we're doing here, there's a very particular, you don't have to do FOIL. If you did FOIL, that's fine. You could do FOIL, but things would start canceling. So you learn that and you say, okay, there's a faster way. If I do the first 2 times 2, which is 4, and then I just do the last, I don't care about the outer and inner when I'm doing conjugate pairs specifically. So negative root 5 times positive root 5. Negative times a positive is a negative. Root 5 times root 5. Okay, 5 times 5 in this case is 25. Square root of 25 is just 5. So when you're multiplying square roots and the inside parts are the same, in this case root 5 and root 5, the answer is just the inside part. So simplifying the bottom, 4 minus 5 is negative 1. The top, there's nothing we can do. So this is very well the answer. Something that might come up, not might come up, but you would probably never see an answer selection that looks like this. So if you're dividing by negative 1, you could just change the signs of the numbers of the terms up top, but you got to change both of them. Okay. Also, if this had just been, like if this was the other way, 5 minus 4 and it was positive 1, well, then you wouldn't even care about the over 1 part. Okay, 22. Simplifying. This is a quick one. So again, square roots on the bottom is bad. So I'm going to multiply by whatever is down there. In this case, it's root 2. So this is going to be 8 root 10 over 2. And it just so happens the outside numbers, right, can cancel. And this will just be 4 root 10. All right, simplify completely. 24. Find the discriminant for the equation. You know what? Let's just do it. Because who knows? Right, outside times outside. This would be negative 28. Inside times inside. And it's a big number. So 18 times 12. I'll have a calculator. So this would be 16, 3, 8, 1, 116. Root 116. Pretty much the answer. But you always want to simplify inside the square root as much as possible. So we can call this 2 and 58. This is going to be 2 and 29, I believe. Yep. And then 29 is a prime number. So this pair is going to come out. Negative 28 is already outside, so 2 times negative 28. So 56, negative 56, root 29. Now, there's multiple ways of doing that, but that's what it is. All right, 24. Find the discriminant. All right, the discriminant is the inside part of the square root in the quadratic formula. So b squared minus 4ac. Notice I didn't put the square root because the square root is not part of the discriminant. It's the inside part that's the discriminant. So when you calculate the discriminant, there's 3 possible scenarios. Either it's going to be equal to 0, where you have one real solution, or you have a positive number, right, greater than 0, and you have 2 real solutions, or it's a negative number, and you have 2 imaginary solutions. So equal 0, and then positive and negative. All right, so what we need to do is figure that out. Now, the only way the discriminant works or the quadratic formula works is everything is to the one side. So notice there's an equal sign in the middle. That's like if you tried to say A, B, and C right now, then you're going to be wrong. Like you're going to be hardcore wrong. So what we have to do is move the negative 3x first. Negative 3x squared. I'm going to move it this way. Now you could move the 4x and the 6 the other way. That works also, but I'd rather move one thing as opposed to moving 2 things. You know, it's just lazy. So 0 is equal to negative 3x squared plus 4x plus 6. So this is my A, this is my B, and this is my C. And we just plug them in. All right, B squared, so 4 squared, minus 4 times A, which is negative 3, times C, which is 6. Now, if this comes out to 0, we have one real solution. If this comes out to a positive number, we have 2 real solutions. And if it's 2 imaginary, or if it's a negative, it's 2 imaginary numbers. My bad, I'm not going to edit that out. All right, so if it's a negative, we get 2 imaginary. All right, and just if you ever see in a multiple choice where it says 1 imaginary, there's no such thing as 1 imaginary, right? Imaginary numbers always come in twos, right? Eyes always come in pairs. You have 2 eyes, so there's no such thing as 1 imaginary number when you're having this conversation. Okay, so 4 times 4 is 16. Minus 4 times negative, 3 times 6. So negative and a negative make a positive. And then 4 times 3 is 12. 12 times 6, 72. Okay, this is definitely a positive number, right? I don't even care what it is, but it's a positive number. For completeness, let's say it's 72 plus 16, 80, 88. But it's a positive number. That's ultimately what I'm looking for. So that means it has 2 real solutions. Two real solutions, definitely, because it's a positive number. It's bigger than 0. Okay. Sketch a parabola on an XY graph for each solution. Okay. So if you have one real solution, you're going to have a parabola that sits on the x-axis. The vertex is on the x-axis, and it sits like this. This is what one real solution would look like. 2 real solutions, you're going to have a parabola that crosses the x-axis twice. And then 2 imaginary solutions will never cross the x-axis. Will never cross the x-axis. It'll be away from the x-axis. Either up or, facing downward. But it'll never touch the x-axis. That's what 2 imaginary solutions look like. All right, 26. We only have 1x squared, so here the square root method is by far the preferred method. I'm going to subtract 25 from both sides. So 36x squared is equal to negative 25. Okay. A rookie mistake would be to try to take a square root now. In this particular case, it wouldn't be the worst thing because 36 is a perfect square. However, if 36 is not a perfect square, most people don't understand what to do. So it's my suggestion to just isolate x squared. Just get x squared by itself. And this is negative 25 over 36. So now, solving for x, we take a square root. Right, you always have to put plus or minus. We get x is equal to plus or minus. So check it out. The negative comes out every time as I. And then square root of the top, square root of the bottom. Right, square root of 25 is 5. Square root of 36 is 6. So we get plus or minus 5, 6i. So definitely going to need to know how to do this. Okay. $27. All right, I want to graph this thing. What form is it in? It is in vertex form. The vertex inside lies, so this is going to be negative 2, comma 3. Outside tells the truth. Right, just like in the last problem, or a few problems ago. So the vertex is negative 2, 3. Negative 2, 3. Axis of symmetry will go through the x component of the vertex. So axis of symmetry will look like this. Through negative 2. It opens down. maybe I should do it in different colors. It opens down because of the A value. Because the A value is negative, so it's going to open downward. The dilation is just 2, right? The A value. And the y-intercept is 3, positive 3. So let's see. So actually, I misspoke. It's not 3. We don't know what it is yet. We have to expand it out. So the y-intercept, we're not sure yet. We have to expand it out. So the way we expand it out, well, we could expand it out, or if you recall that it's when x is equal to 0. The y-intercept is when x is equal to 0. So if I plug in 0, I get this would be -2 for everybody's hitting me up. So this is going to be -2 times 2 squared plus 3. So 2 squared is 4. So -2 times 4 plus 3. -2 times 4 is -8 plus 3, which is -5. That is the y-intercept. The y-intercept is -5 when x is 0. So -5 is down here. We can mirror that across the axis of symmetry. And then it's going to look like this. All right. Domain, all real numbers, always. And the range is going to be from -infinity, because it opens downward, up to the maximum, which in this case would be 3. Okay. Yeah, we'll leave it at that. Okay, so 28 is just like the last one, except we're graphing two equations. So graph the same parabola as you did in 27. Okay, so this is the same one from the last one. So, okay. So -23, or -2 comma 3 rather, goes down, and then graph the linear line, -x minus 3. So -3, -x. Okay. Okay, so I shaded in there because it's less than, right? It's less than or equal. So we have to shade really what happens is you shade everywhere underneath this line. Right, but and then for this one, you're shading inside. Okay, so what I want to focus on this question, I'm going to deviate kind of from what it's saying. If I'm given a picture, right, and I want to know a solution, the solution is always in the overlapping parts. So in this one, it would say, okay, is 0, 0 a solution? Right? That's the question that I'm introducing here or proposing. Like I'm asking the question, is 0, 0 a solution? And it's no, because it's not in the shaded area. So if I take 0, 0 and I start to plug it in, right? 0, 0. This would be 0 is greater than, what is this? -5. Right, that's false. And that should make sense because it's outside of the shaded area, right? It's outside the shaded area. Here, 0, 0. Is 0 less than -3? No, it's not. Again, that's false. So I'm saying this because if you have a problem and, right, so let's just say you have this problem and, or this picture rather, and the question is, what are the equations for this graph? Well, if you take 0, 0 and you just start plugging in the 0, 0 into the equations, the one that's true is your answer. That's all I'm going to say about that. All right, 29. It's the last one. So we want to write an interval notation. So interval notation, this is with parentheses or brackets, right? That's what interval notation is. So if you see an inequality, a less than or equal sign or greater than or equal, you can always cross those out. Okay, we want to know when is it increasing. So increasing is uphill. So increasing is going up like this. And there's only one, right? There's only one picture for increasing. There's only one moving from left to right. There's only one uphill, and it's right here in the red. So, you always want to compare that to your answers and make sure that the parts match up, right? If it's only one uphill part, then you should only have one interval, right? If it's two uphill parts, then you'll have two intervals. Here, this is going to be, and it's always in terms of x, always. So -4 to -2. With parentheses, right? Remember, always use parentheses. So the increasing, this uphill part is from -4 to -2. The decreasing part, again, moving from left to right, there's two downhill parts from left to right. So there's 1 and 2. So I have 2 going downhill. So I'm going to have 2 answers. So one answer, or one interval, is going to be from -infinity up to -4, right? Because that's where this first downhill portion starts, right? It's coming from the arrow, right? The arrow means infinity, in this case, -infinity, right? In terms of x. So coming from left to right, or I guess view the camera coming from left to right, going this way, you're coming from -infinity, and then you stop at that most bottom part, and that's -4. All right, the next downhill part, right, because I don't care about this red line, starts up here and then goes down. So it starts at -2, parentheses, always parentheses, and it goes down to x equals 2. So from -2 to 2, that's downhill, right? It's going downhill. And we union them together because it's two separate pieces. So again, it's always x. It's always from left to right. And if you think about it, start from the most left and then just work your way right. And it's always x. So coming from -infinity is downhill up to the first hill or valley, however you want to look at it. And that'd be -4. Then it starts uphill. So from -4 to the top of the mountain is -2. So -4 to -2, that's increasing. And then it starts over downhill again. -2 down to whatever point. And it's always parentheses. All right, man. Hopefully I know it went quick. I did speak kind of fast, but you can always pause and listen to what I said again as many times as you want. So good luck. Let me know if you have any comments. Good luck.